I started my first entrepreneur venture when I was in grade 9. I was in tech class and I was bored. So I took my lunch, which was 2 baked potatoes, and I engraved them using the laser engraving machine, and I sold them. Now that is a pretty innovative idea, and that was my first venture. So I sold engraved potatoes. And throughout my journey of selling engraved potatoes, I have produced a lot of waste. I had a whole pile of discarded potatoes that no one really wanted to buy, and I had no way of getting rid of it. So being the environmentally conscious person that I am, I looked for a way to get rid of them. And that solution was composting. So I built my own compost bin, I put my whole stack of potatoes in it, I put it in my backyard, and I thought that everything would go swimmingly, and in a few months I'll end up with this high quality fertilizer. Well, I was wrong, because the next morning, there were potatoes scattered across my yard, and my compost bin was torn open by raccoons. And that event traumatized me. And it scares me to this day. And that was a direction that kind of motivated us when we were brainstorming for an idea. So we have a problem. Our problem is that waste management systems within Ontario are extremely cost intensive, and they're really inefficient. Last year, it costed taxpayers $3 billion just to get rid of our waste. Furthermore, 72% of the organic waste that we threw away didn't end up being composted. Instead, they're being sent directly to landfills, where they pollute our environment and make greenhouse gases that adds to climate change and global warming. Finally, the solution to these problems, composting, is extremely hard, it's complicated, it's dirty, it's smelly, and no one really wants to do it. So we took a survey, and basically what these numbers tell us is that people do want to compost. And there is a demand for composting. However, there's a lot of issues with composting that needs to be solved. And that is what sparked us to create Tess. Now, Tess is a easy-to-use compost bin that is composed of 2 elements, I have a prototype right in front of me here. So it has a reusable outer layer made of bamboo, so reclaimed bamboo, and a completely decomposable inner layer made out of plant fibers. Now, what this allows consumers to do is to throw away the entire inner layer once it is full, and they do not need to churn it or maintain it like any other examples of composting. In addition to that, we have involved 2 technologies into our inner layer. We have a carbon filter that eliminates all odors and smells so that it will not attract pests. And you will see a diagram of this in page 4 of the booklet. We also have plant enzymes embedded within the inner layer, so hemicellulase, amylase, and xenolase. And what this will do is to speed up the rate of decomposition and produce more fertilizer quicker. What this allows us to do is to save on costs. It will save taxpayers money by reducing the stress on our waste management systems. It will also save the environment, as there will be less compost and less organic waste going into these landfills and polluting our environment. It will also make composting accessible to everyone. So even if you're in the suburbs or in a tiny apartment in downtown Toronto, you can get access to composting easily and efficiently and at an affordable price, as I'll show you later on. Now, let's get on to our market. So what we're aiming for. So we see that in Canada, there are a total of 13.4 million households that dispose of waste regularly. That is our total available market. And we see that the federal government spends $1.3 billion annually just to get rid of our organic waste. That is our serviceable available market. Out of that, we think that we could capture 2.8 million households, and that is our kind of projected available market, simply based on a conservative estimate that will capture around 20% of the available market. Now, what is our market opportunity and our market validation? So we see that within Ontario alone, there are 2.9 million households that are already composting. So that's either with their own technologies or with the Green Bin program, they're already doing this. So there is a demand for composting. In addition, the Ontario government spends an additional $1 billion just to get rid of waste, and that is a portion that could be allocated to Tess if we do manage to develop the technologies correctly. Now, what is our go-to-market strategy, and how are we going to get Tess to your hands? Well, we have 3 main streams. First of all, there is a B2C stream, so we're going to sell directly to our customers when we launch. Second of all, we're going to buy shelf space so we can get Tess onto store shelves and make it more accessible to everyone. And third of all, and this is our ultimate goal, we want to collaborate with municipalities so that Tess can be integrated within their own waste management systems. Now, our business model is as following. We will sell the external shell, which is reusable for Tess, for $20, and we'll sell Tess refills for $5 each. And we estimated that for a family of 4, they will use about 1 refill per month. Now, our competition. So as you can see, this slide is pretty sparse because we do not have that much competition. The available methods are extremely inconvenient, and if you are the users of green bins, you will know how cumbersome it is and the smell that it could produce during the summers and how much pests it can attract. Our only direct competitor is actually Greenlid, and what they lack is the technologies that I mentioned earlier. So the carbon filters and the enzymes that I mentioned. In fact, we took a trip to the Markham City Council. We walked in with a bright smile and a firm handshake, and we met a few people. And what we got is an overwhelmingly positive response from them. They loved our ideas, and they would like to discuss any further interactions between Tess and the city government. And that is extremely encouraging. I also went a step further, and I contacted some land developers from Remax and my candidate for my local member of parliament. And their responses are also extremely, extremely positive. Now, what I've talked about is a huge project, and I need a good team. So my team of dedicated and determined teenagers and students are all involved with me to make this goal possible. So that is my team. Now, finally, we would like to thank you for listening to our presentation, and we would actually like to invite each and every one of you to contribute to our cause by throwing away all of your organic waste during dinner into our prototype so that we can begin this first step of compost for everyone. Thank you. So I assume you have questions? Oh, sorry.
What is the cost for you guys to produce your prototype? If you're charging $20 for a shell, $5 for the refill?
Right, so that is a good question. And the reason why our production costs weren't included in this presentation is because we still only have an initial prototype and we aren't sure of the production costs yet. But we still did our research and we found some quotes online through other international suppliers. So our water shell, it is made from reclaimed bamboo, so it is an expensive material, but it is lightweight and it is aesthetically pleasing, which will belong great on a countertop, right? And because of that, the costs are higher if it's made of plastic. But we choose to make it from this material because we want to continue our environmentally conscious message. And for our inner layer, we think the costs for that, for an inner layer, I think that with our technologies, if we streamline the manufacturing process, we can get the costs down dramatically. So for both of these modular elements, we want to make at least a 50% profit margin. And that is our kind of steps going forward. So that is something that we have to look forward if we can have a working prototype and keep on improving them. I hope that answers the question.
Great product, great presentation. Congrats
Thank
on
you.
that. Just wasn't clear on one thing. The product is in the household. How does it get to, where does it go after you?
Right. So I get a question. So where does the compost go? Now here's the thing about composting. It is a process that actually makes a useful product out of your trash, right? So with your waste, when you compost them, because of our plant enzymes, it takes a month for your food waste from dinner, and it turns it into an extremely nutrient-rich fertilizer that you can use on your yard, that you can use on your house plants, right? So essentially, composting reduces your waste to something that is useful, so you can use it on your own house plants. Because of enzymes, the process is quickened up, so it is already more convenient. So with this, we had a cover plant for it, so we had a lid plant, but because our 3D printing machine doesn't have the biodegradable material, we decided not to include it for today, but there will be a cover, and you can put it in your garage or your backyard and wait for it to decompose.
The process of composting actually creates heat as
Yes,
well.
it does.
That's one of the byproducts, so I'm interested to hear how you're gonna deal with that. And then the other challenge with the green bins is actually not coming from the outside in terms of insects, but from the inside, from the food itself, with, you know, the maggots and all that fun stuff. So how are you gonna, with your filters, prevent that from happening?
Right. So to answer your first question, which is the heat problem. So this this inner layer, if I do tear it up for you, it is a double layer layer, right? Because we do have to include the filters and the enzymes. So it is double layered. So you can take a closer look if you want to. I should pass it to you. So it is double layered. So it is kind of insulated. And the time is up. But yeah, I hope that answers your first question. And we'll talk more afterwards if you're still interested. Thank you.